So we're getting ready for our quiz today. We're going to work on just doing some practice today, a little bit whiteboard review in general. Let f be the differentiable function between f of 0 is negative 5, f prime of x is less than or equal to 3. What is not a possible value of f of 2? Again, when we do this question, picking the biggest or the smallest answer is probably your best bet. There's not a good reason for why it would just randomly be in the middle between those, right? We're talking about like what is the biggest it could possibly be, what is the smallest. When in doubt, graph it out is always a good plan. Okay, so when I look at this graph, f of 0 is negative 5. So 1, 2, 3, 4, 5. The only other thing we know is what is f prime of x, or f prime of x is less than or equal to 3. I want to know f of 2. Okay, so I want to get out here to 2. What does it mean if f prime of x is less than or equal to 3? The slope is 3 or less. So let's do the most extreme version of that. The slope is 3. That's the most extreme. So if the slope is 3, I'm going to go up 3. So I'm going 1, 2, 3 over 1. 1, 2, 3 over 1. That's as high as my line could possibly go because the slope is 3 or less. It could go like this, or like this, or like this, or like that. But this is as high as it possibly could go if the slope is less than or equal to 3. So which number can I not reach? 2 is too big. The biggest I could possibly get was right here to 1. 2 was too big. Okay. When you draw a picture of that, it makes a lot of sense. If you're just trying to look and think, it might not be as good. Drawing a picture, when in doubt, graphing it out, always is going to help you figure that out. Questions on that? All right. So today, before we take our quiz is 5 minutes long. It's not going to take you long. We're going to make sure we just are reviewing for the test. So today is a whiteboard review day, but I'm not doing whiteboards because COVID's annoying and I don't want to wash all the boards and the markers and everything else. Okay. And just especially for this review. So on your bell work, and some of them you don't have to write anything down, you are answering some questions. You're talking with your neighbor. You're going to answer them. I'm going to make you show me answers, all that good stuff like we always do. Okay. So here's a graph. It is a graph of f prime. Talk with your neighbor. Figure out when f has a max and come up with the correct justification. Where does f have a max and have the right justification? Talk. Show me with your fingers. Where do you think f has a max? You have a max at x is equal to 7. Before you even write that down, though, I would expect you to have a justification. Michael, what's your justification here? F prime changes from positive to negative. That is the only justification you can have, and have it exactly like that. Except, like, oh, you use the word goes from or switches, maybe, but everything else is right. Don't say the graph of f prime x. It's just kind of redundant. You know what I'm saying? Because you're already talking about f prime. That's like saying the student that's sitting there that's named Luke. I can do that, but that's just kind of redundant. I don't have to say that. X equals 7. Technically, negative 10 is a max as well. That is not what I'm going to do today because today I'm asking about relative maximum minimums. This is a min. This is a max. Endpoints could be mins as maxes as well. If you label those and you know that they alternate, you know that this is going to be a max and that's going to be a min. We'll do that more in the future, but just heads up. Okay. All right. Let's figure out when f is concave up. Come up with an answer. Come up with a justification. Show me with your fingers. How many intervals is f going to be concave up? We're saying 2. Talon, when did you say f is concave up? Negative 10 to 0 and 4 to 6. That is where we're concave up. Alana, why am I concave up there? F prime is increasing. That is the only justification you should have, besides maybe f prime has positive slope. I like increasing better because you won't screw it up. Questions there? Let's do it again. This is the graph of f prime. Tell me where f has a POI. Justify it. Talk to each other. Go. Show me with your fingers. How many points of inflection does this graph have? Okay, we're not there yet. There are... Oh, we're a lot of wrong. Jesse, where do you think there's a point of inflection? -2 and 3. What is your justification for a point of inflection? F prime has relative extrema. That is where a point of inflection happens on an F prime graph. Yes, sir. Yep, because remember, F prime, when we find points of inflection, it can be when F double prime is 0 or undefined. So F double prime would be undefined there, but that's fine. It's a maximum or a minimum. That's why I like using relative max or minimum, because it makes it really simple to understand. Jalen? No, points of inflection never happen on endpoints. Points of inflection are always in between, because it has to be where it changes signs, and it's not going to change signs at an endpoint. Don't. You would always use it for what we're describing. The slope isn't 0 there. So the question is, when do I not want to use those? It would be if the question is, when is the slope 0 only? That would be the only time I wouldn't use that. Or when is it not differentiable? The function is not differentiable at -2, but that doesn't allow it to not be a point of inflection or anything else like that. All right. When is f increasing? When is f increasing? Come up with an answer. Talk with your neighbor. Show me with your fingers. How many intervals is f increasing? Bottom out of when am I increasing? -9 to -2. Good. And when else? Or no, my bad. You said it right. I said it wrong. -9 to 2. And when else? And 5 to infinity. Those are the two places. Boom, boom, and boom. Why is that true, Luke? F prime is positive. Good. You have a question? So here I would use brackets because I'm talking about a first derivative question. Again, I'm not that concerned about it. No, I do not. It's brackets, first derivative, parentheses, second derivative. So if I'm talking about increasing, decreasing, it's brackets. Talking about concavity, it's parentheses. I would not count you wrong. You only use, and you never use brackets on infinity. Let's do another one because this is the place we screwed up here. Tell me when f has a point of inflection. When does f have a point of inflection? Look at the board, get an answer. Show me with your fingers how many points of inflection does this graph have? It's 2. It's there and there. Why? Because f prime is what? F prime has relative extrema. Great. Those are great questions. That'll help us for the quiz, but let's just talk about the future in terms of we're taking a test next week. We're just going to practice a few more minutes, okay, just to utilize our time correctly. I got 3 more examples. Okay, so do this on, imagine like this is another bell work. Do this on your bell work paper. The table gives you selected values of f. If f is twice differentiable from 1 to 5, which of the statements could be true? When in doubt, graph it out. Think your way through it. Go. Here we go. When in doubt, graph it out. This is a graph of f. Okay, this is a graph of f, so keep that in mind. They're asking me questions like, is f prime negative or is f prime positive? That one should be the easiest one. This is a graph of f. What would I look for on f to talk about f prime? Slope. What is true about the slope on this graph? The slope is negative. Careful. The slope is negative. So if the slope is negative, it's not C or D because slope is negative. F prime is negative because the slope is negative. Then we're talking about is f prime increasing or decreasing? What are you describing if you're describing f prime either increasing or decreasing? It is a concavity question. F prime increasing or F prime decreasing is a concavity question. What would you say is true about the concavity of these dots right here? It's up like a cup. So if it's concave up, what does F prime need to be doing? F prime needs to be increasing is B. Now, a lot of my students will say, what is happening to that slope? It's getting closer and closer to 0, right? And so if your slope is getting closer to 0, a lot of students will say, well, that's decreasing. No, because the slope from here to here, I went down 4, so the slope is -4. And then the slope, or -5, sorry. Slope is -5. Then the slope is -4. Then the slope is -3. Then the slope is -2. Those numbers are getting bigger, right? Because negative numbers, the closer you get to 0, that's a bigger number. Okay, so those are increasing numbers. A little bit hard to think about at first glance, but that's what we're doing. Two easier ones here. Last two. We've got a function right there. F prime, and F double prime are all going to be negative. Which of those graphs could represent F being negative, F prime being negative, and F double prime being negative for the whole thing? Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. What you got? Lots of 2s. Let's see if we're right. F is negative. What does F is negative look like on an F graph? It's below the x-axis. All right, they're both all below the x-axis, so that's good. F prime is negative. What does F prime look like if it's negative on an F graph? Decreasing. The slope is always negative. So it's not A, because right there the slope is positive. Great. It's not A, because right there the slope is positive. Right there the slope is positive the whole time, so it's not C either. Last one is F double prime is negative. If F double prime is negative, what does that tell you about F? Concave down the whole time. That one is concave down the whole time. That one is concave down for a little bit, and then concave up for a little bit too. It switches. Good there. Last one. This is my favorite question in calculus. I don't know why. I just like it. Put these in order from the smallest to the largest. So they're giving you a graph, they're giving you a point, and they're asking you some information. When they do this question, it'll be multiple choice, and they normally make you pick like F is less than 2, is less than whatever. The key is one of them is going to be positive, one of them is going to be negative, and one of them is going to be 0. Identify which is which. Go. Here we go. Show me with your fingers what is going to be true about F of 2. Is it positive, 0, or negative? F of 2, positive, 0, or negative? It's 0, because it is F. Here is 2. Oh, that's 0. F prime of 2, positive or negative? What is F prime at 2 going to be? Why is it positive here? It's increasing, has positive slope. F double prime at 2 has got to be then negative. Why? Concave down. F double prime is talking about concavity is concave down. So if I were to put these in order from smallest to largest, it would look like this. F double prime at 2 is less than F of 2, and that is less than F prime at 2. That is what it would look like multiple choice. I guarantee you that's going to be on your final because I like that question. I'm going to throw it on there because that's what I do. Questions there? All right.